All right, this section is going to be relatively short. Momentum and impulse, these are words that I'm sure you've probably heard before, but again, like many other words, probably haven't quite understood what they mean in physics. So let's go ahead and get started. So you see here on the screen a butterfly and a truck. In class, I would have had a class discussion with this question, which do you think has more momentum? And many people go back and forth, and people's first inclination was, well, of course, the truck has more momentum. And then there are some people that start thinking a little bit farther on this, especially when I ask the question, well, is it possible for them to ever have the same momentum? Or is it possible for the butterfly to have more momentum than the truck? And then when I ask these questions, usually people start thinking about the fact that, like, well, what exactly is momentum? We've heard that word before. Many people hear it in a sports context. When two teams meet to play each other, sometimes you'll hear it said that one team has the momentum going into the game. That simply means that they have probably been winning up to that point, which means they are going to be hard to stop because there's this mental thing with sports. Hard to stop is the key. So we really need to look at, well, what is momentum in the first place here? So momentum is officially, if you look it up in the Wikipedia or whatever, defined as the quantity of motion of a moving object or mass in motion. That doesn't really give us exactly what's going on. So practically speaking, it's a measure of how hard it is to stop a moving object. Now, emphasis on moving object, because if we go back to the butterfly in the truck, you have to be moving to have momentum. So really the answer to this question is I do not know which one has more momentum right now because I do not know their speed. The reality is if either of both of them have no speed, if they are not moving, then neither of them have any momentum. In other words, if they are not moving, it's just as easy to stop the butterfly as it is the truck because they're already stopped. So it's this idea of motion that comes into play with momentum, but it also has to do with mass as well. So if you can imagine the truck is moving and the butterfly is moving, it's really clear to see that between those two, the truck is definitely harder to bring to a stop. And it's not just because of its velocity, it's because of its large mass. This brings back into reality the concept of inertia and the fact that mass is inertia. And the more mass something has, the harder it is to stop. Well, momentum is a slightly different concept because it brings not only mass into the picture, but velocity as well. So this is our equation for momentum. P equals mv. As you can see in the picture here, P is momentum. Really important that you write down these units, this unit in your notes. We get the unit from the rest of the equation, which is mass times velocity. Mass, the unit is kilograms. Velocity, the unit is meters per second. So we simply put those together and we don't make any other, with force, we named a unit called newtons. We don't do that with momentum. We simply say kilograms times meters per second. So we just say kilogram meters per second. That's how we say the unit for momentum, kilogram meters per second. And it's a really, really simple equation, P equals mv. Let's look at a few examples. Very, very easy to do these examples for momentum. First example, what is the momentum of a 7-kilogram bowling ball moving at 10 meters per second? So if we look at this, you're given the mass of the bowling ball, you're given its velocity, m, and v. We want to know momentum, so the equation is P equals mv. We plug in the mass, we plug in the velocity, 7 times 10 is 70. This bowling ball has 70 kilogram meters per second of momentum. A 1,000 kilogram car has 22,000 kilogram meters per second of momentum. They give us the momentum there. How fast is the car moving? Same thing, but they're giving us different things. In this one, they give you the mass, and you're given the momentum now, which is P. So it's going to work out slightly differently, but it's the same equation. P equals mv. Our P, our momentum, goes in for P. Mass is 1,000, and if we divide by 1,000 to solve for V, you will get 22. So this car must be moving at a speed of 22 meters per second. That's the way this equation works out. It's really, really simple. Those are basically the main two examples of problems that you'll be given regarding just momentum itself. But as you can imagine, this goes a lot farther. So here's the thing. If momentum is a measure of how hard it is to stop a moving object, we can also maybe think of that as of sort of how hard it is to simply change the momentum, change the speed of that moving object. And so the idea is that we can change this momentum. Everything I've talked about so far has been just for something moving at a constant speed, having a constant momentum. But the fact of the matter is that this momentum can be changed, and that's really the bulk of what we're going to talk about in this section, and that's what the next video is about.